Good morning, folks. I'm Paul Cooper, the Vice President of Engineering at Zeta Networks Limited. I'm here to talk to a little bit about how the 5G cellular industry and Industry 4 converge. Just to give a little bit of a background on Industry 4, this is about the digitalization and modernization of processes across many industry verticals. Typical ones will be manufacturing, but also included in there are warehousing, medical, automotive, etc. So a little bit of background about me. I'm the engineering and delivery lead at Zeta Networks Limited, which means I'm responsible for the development of our solutions and the delivery into our marketplace. I recently completed the 5G Encode program, which is a government-led initiative sponsored by DCMS to study how 5G cellular could be used in an industrial context, specifically in manufacturing. And I worked with a number of collaborators on this project, and we'll have a little bit more about that in a few moments. My background is telecommunications, and I've been in the professional services arena for a number of years now, with a passion for developing software solutions that create value for service providers. Okay, a little bit about Zeta Networks. So in the past, IT networks and telco networks have been a little bit separated, and you plumb them together with some big pipes and push data services through those pipes. And typically this relies on over provisioning, and it's not very flexible and quite difficult to adapt. As 5G enters the marketplace, the disconnect between enterprises and service providers has been looked at and included into the 5G technology. So this means you've got more control over the data as it passes from one domain to another, i.e. from a telco into the IT network. This opens up a whole host of opportunities for the enterprise application developers to really integrate with service providers and control their data needs on a much more adaptive and flexible manner. So, for example, you would create an application that was driving an industrial process. If somebody needs more bandwidth, you can actually request that from the network. You don't have to go through some long procurement process as has had to be done in the past. It's still an emerging market, but Zeta Networks is right in the front of that. We've got three solutions that we have in our portfolio. The first is the Automate solution. This is all about connecting things and making sure that we can connect and manage the elements of the network. Then we have our Adapt layer. That is about managing the end-to-end service of the end-to-end performance of the service going across the network. So if you've got a video stream and it goes cranky, you need to know where it's gone cranky and potentially why, and then you need to do something about it. So we have a closed loop system that looks at it, says it's gone wrong, and then adjusts the network. And then the sort of panacea of all things software related is to integrate your applications so they can control the services programmatically, and you don't have to ring up a support agent or change a support contract. You can have a flexible pay-as-you-go type data consumption model. Looking at 5G, just stepping back to what the overall objectives of 5G as a technology set out to achieve. This is the first one was about greater capacity. I mean, often you find this as technologies evolve, you want more and you want it faster. So there's a feature called EMBB, which is about providing a much bigger data pipe through to each consumer that's using the radio network. Then there's adding devices. So there are limits on how many devices you can attach to a cellular network. As IoT becomes more and more dominant in not only in the consumer space, but also in the factory and commercial spaces, we're going to have to connect a lot more devices to the network, and those devices need to be managed. And they're quite often low tech, in as much as they have to be low power, because there's several thousand of them, and you have to power them with batteries and solar panels, etc. And then finally, we've got ultra fast, reliable data transfer. This is where you're taking lag and latency out of the network. In a manufacturing environment, if you're printing circuit boards, your control system needs to be very, very responsive when sending commands to and from the actual machinery doing the work, for the print head or the robot, whatever it might be. And then finally, you need to set the network up so you're slicing the data transport layer so that depending on what applications are using 5G, they get the right bandwidth and priority when they need it, as it leaves the 5G domain and enters the rest of the network. And then you need to control it through that network, of course, to the endpoint, whatever that might be. Looking at the 5G encode project, we were looking at 5 big use cases for industry. The first one was augmented and virtual reality. So this was about training and delivering support content from an agent in one location to operatives in multiple other locations. So virtual reality, many of you will be familiar with that. That's things like those virtual reality headsets you put on. There are a few on the market. And then augmented reality was much more interesting development, and this is not necessarily 5G tied, but we were doing it over 5G to understand the lag and the user experience. But this is where you put on a headset where you can actually see what you're working on through the headset, and then auto cues and prompts come up in your visual range and allow you to perform actions whilst either instructed or looking at instructions that are available to you in the digital content, such as manuals, etc., that come up on the headset. Very interesting new developments going on there. The second use case was about asset tracking in and out of factories. This is where you put tags on things and need to know where they are. We saw some significant time savings when you know where something is in your factory and you don't have to go spend 10 minutes looking for it. And as you can get that down to look it up on the server, I know it's on that shelf in that storeroom, suddenly you just saved 9 minutes of work time, which when you add that up across the life of a process and the number of staff in the factory becomes a significant saving. And it doesn't have to be down to the last centimetre. Other use cases have been looking at really accurate asset tracking. We just looked at, is it in this room or is it on this truck? Those type of use cases. We did some out of factory asset tracking where we were looking at the material coming from the producer, which was another factory, down the motorway and into the production factory. We had some interesting findings there, so I'll come on to those later. There was some difficulty moving it up onto the public network and down again. Then we had a couple of use cases that we're looking at. The ultra low latency. This was around liquid resin infusion and the automated preforming cell. So automated preforming control on the cell is like a big printing process, and you need to very rapidly change what it's doing as it's printing to print the right parts. And the liquid resin infusion was about flowing a liquid through a part, and then it was going to be baked in an oven. Again, we saw some really cool results there. The liquid resin infusion, we found that the bake time on the ovens, we were running them for 20 minutes longer than necessary. The actual, once you've got the sensors in the ovens, you can see the thing was fused and you were cooking it for longer than needed. Again, that saved time in the process and energy costs on the oven, running the ovens. So these industrial use cases have value, not only in the 5G domain, but also just generally as we go through Industry 4. And then we had 3 supporting use cases, which are around network probing and neutral hosting and the domain slicing. These were relatively successful. The probing could tell you where the traffic was in your network and how that was running. Neutral hosting was about moving traffic on and off network. We did experience some challenges there with public network operators. And then the single and multi-domain slicing was about managing the data services themselves in the network. Just to introduce a couple of terms that you might be familiar with around 5G, there's NSA and there's SA, and it's important when you're designing product to understand which market you're targeting. So non-standalone, or NSA, is where you attach and authenticate via the existing 4G network and then are pushed up to a 5G network when you need that high bandwidth, high speed data. A 5G standalone, or SA, is when you are doing a direct connection to a 5G network. So you're actually coming on and being allowed access through that 5G radio. There's a big difference here in what happens in the protocols under the hood. In NSA, you get whatever services the 4G has available to it, and they are pre-configured. With 5G, during the protocol connection process, you actually negotiate the services you're going to use as part of your connection. So at the moment, most of the commercial networks are running NSA. They will move to SA, but we're not quite there yet. The test we did or the trials we did in 5G encode were a 5G standalone service where we could do that negotiation. To introduce another concept, there's the 5G ORAN. So in the past, the main suppliers of telco networks have provided complete systems to the service providers who are purchasing them. So there are some big tier 1 telco suppliers that I'm sure you're aware of. When 5G was being architected, there was the governments and the forums that run telco said, look, we want to split up and break up these monopolies. So they introduced a concept called OpenRAN. This is where the functions of the 5G or of the network are split up into component parts and then can be placed in different places, different parts of the network, and provided by different suppliers. And as long as they comply with the various interfaces, then you can connect different pieces from different suppliers together. That all sounds great on paper. Of course, there's IoT or interoperability testing to be done to make sure all these parts work together when you assemble something. But ultimately, this will break the monopoly on providing RAN networks and the core networks, and enable more efficient use and lowering the cost really for the service providers and ultimately the end consumers. We also got some advantages. You can put some of the functions into some of the public cloud operators, again enabling more efficiency in your business models. Now, when you're designing solutions to access a 5G ORAN, you're likely going to have touch points with the UE, which is the user equipment, the UPF, which is the user plane function, and the data network. The other parts which have been virtualized are really with the infrastructure or the network supplier themselves. But I just want to draw your attention to this concept of the ORAN and make sure that you're aware of when you're building things, what you're likely to be touching. Extending the ORAN or the network out, there's another concept called mobile edge compute. I'm sure many of you are aware of this. This is where the applications that are processing or doing the heavy lifting of data are placed in your solution. So you might have your sensors out there on the UE domain, and then you've got an application that's managed on the mobile edge. Now, the mobile edge might be an on-premises piece of hardware, or it may be in a cloud-provided solution. The cloud providers nowadays will extend out into enterprises, so you can really get that latency down and still use commercial cloud. Again, consider this when you're designing a system of what you need and where, because if you get your large volumes of data into a MEC, then you can do some real data processing and again analyze what's going on in your end-to-end industrial process. And we saw this with the aggregated preforming cell. We could do defect detection at a much higher rate than it could be done when you had the processing down attached to the robotic arm. And finally, just to cover a couple more of the terminology areas, there's not the network virtualization, virtual functions and slicing. So as you virtualize things, you need to put network slices, which are the connections across the data network between those functions, and make sure they've got the capacity and bandwidth to support each virtualized function. So again, you need to consider what applications are going to use a network, where that data is going to flow, and then what slices are needed to transfer that data between those virtualized functions and the endpoints in the network. And again, this is where Zeeta Zeetta solution will help simplify that process. Now, in the past, the spectrum of the radio networks has been controlled by Ofcom and auctioned off to various users. Now, you'll have heard of spectrum auctions. There was a big one in 2G, an even bigger one in 3G, a massive one in 4G, and of course there's been the same with 5. And this is across the globe, but we can focus on UK Ofcom today, as we're doing a UK event. So what Ofcom have done for 5G is they've changed the strategy and approach slightly. So what they realised was that by selling every piece of spectrum to the main operators in the UK, they were restricting evolution and development of devices and also smaller vendors coming into the cellular space and competing with the main suppliers. So what they've done this time is they've created a shared access spectrum, and you can see that there in the middle of the chart here. And what you can do as a small or independent test lab or design function is you can apply for shared access spectrum. And if you keep your license to low power in building, it's very likely you're going to get a license from Ofcom. They have to check that no one else is using the license in the area you're in, and then they also need to understand how much bandwidth you need for your device you're developing. But it's very good for test lab development of solutions. It will also be very useful for the IoT rollout, because you don't want to have to go connect. You don't necessarily want to have to connect all your IoT devices for a public network the whole time. There are other pieces of spectrum. So there's in the sub 6 gigahertz domain, there's a 3.4 to 3.8 gigahertz spectrum, which you can apply for a trials and innovation license on. And if no one else is using it, and if the owner of the license that was auctioned off agrees, then they will give you a trials and innovation license. And we use this in the 5G encode project to stand up an in-building standalone network on commercial devices. This was mostly related to the fact that the commercial devices at the time didn't support the shared access spectrum. So it depends really on what you're doing, but those options are available to you from Ofcom. You do need to look into it and make sure that you understand what you're applying for. But it's really the shared access has changed the way companies can evolve solutions in a 5G environment, or any radio environment, to be honest. In the past, you had to have things in lead boxes and Faraday cages and all sorts of exciting stuff, or have it cabled down. Now you can actually broadcast here. There are a couple of other spectral areas that to be aware of. There's the low range, which is the 700 megahertz range. This is already in use for other radio. It's being that radio is being retired and being reassigned for 5G use. I think there's also some plans to reuse some of the GSM spectrum for 5G, which will, whilst you won't get the massive bandwidth across it, will give you huge range, which is missing. As you increase the frequency in use, the effective range you can get, the distance away from the antenna reduces, and it's sort of a curve like that. It's not a linear. And then for very local proximity devices, their 26 gigahertz spectrum has been identified. It's I haven't used it myself, but I know it's available now for trials and innovation. But this is for very close proximity, possibly in-room, in-building IoT type environments. So one more thing to say on this. When you're applying to Ofcom for something, you need to allow time in your schedule. Best case we had was a 6-week turnaround on license. I would allow 8 to 10 weeks. If it's your first time through the application process, you may get questions back that you need to go off and an answer before you're actually allocated license. Things often things like the antenna you plan to use, there'll be questions you have to go to the manufacturer and ask them exactly what that antenna does. Ofcom are really good. They've got some really good technical help guys. When they have questions, they will guide you on what they're looking for to the best of their ability. Finally, a few challenges on things to be aware of when planning to use 5G in any environment, but we're focused on industry today. One of the key things we noticed during the 5G encode trials were the entry cost can be pricey. Now, this will come down over time, and it is dropping all the time. But right now, you have to be a bit careful that when you do your business model, that you factor in the cost of the 5G and how long that system's going to live. I'm not an expert on business case planning for commercial systems. However, I would say just take care that you look at the cost of the radio, the cost of all the elements that need to go into the system, and plan those in, and then write them off over a significant period of time if you can. Some of the and if you're doing design and building products to use 5G, you don't need to buy a full system. Look at entry-level testbed solutions. Each one has their pros and cons. Some are good value but have restricted feature sets, and some are more expensive and have fuller feature sets, as they say. So pick a little bit carefully. Don't just take the cheapest one you find off the marketplace. It could be not quite what you're looking for, and it could not be working as you expect as you develop your product. It's worth looking at vendors who say they are fully 5G standalone compliant, because that means that when you've developed your solution, you know that it'll work in a standalone environment, and actually reverse engineering it back into a non-standalone is going to be simpler. We also found with compliance that not all industries are cellular ready. Some of the experience we had out with the manufacturing facility is it was a chemical process in this case, and it was an explosive environment. So it had everything that was in that environment had to be ATEX compliant, and we couldn't deploy 5G cellular into that environment because nothing had been compliance tested against ATEX. No parts of the RAN, and no devices. So keep this in mind. And actually, this is a huge area for development of devices and radio heads, because there are many industrial processes that have to comply with standards that traditional cellular hasn't really considered. In terms, when thinking about resilience, so we talked about ultra low latency solutions. That you also have to plan in a layer of redundancy, because if you've got a critical factory process, radio does tend to have some variation in it, and what you don't want is a radio going offline or something changing whilst your factory process is doing something, because that something could be really expensive, like printing a carbon fibre wing for an aeroplane or a body shell for a car, for example, and you don't want to have to write off all that product. So you want the system to be tolerant to abnormal events, whatever they might be it interference or power outages or just something going past with a big metal side on it. So think about radio design and make sure that you've got multiple layers of radio coverage in the areas that are really key to your business, and also look at the back end network, so you haven't got any single points of failure through that as well. So if you're overlaying two radio units to give resilience at the radio level, and maybe you've got different frequencies in there as well, then make sure those radio units are connected to separate DUs, which are the distribution units, and those DUs are connected to different CUs, which are the control units. Otherwise, you're creating single points of failure upstream, which could be affected by power outages or interruptions in an IT network. So you do have to think about resilience early on, make sure you design it in. Again, if you're in a testbed environment, this is of limited value to you. But if you're moving into the product environment and the full rollout, then resilience is key. Final topic is security. Now, there's a lot of discussion around security. I'm not a cyber expert by a million miles. I do know that the radio layer itself is extremely difficult to intercept. There are encryption keys that change every few milliseconds, or depends what you set it up to, but typically that's what happens. So breaking into one of those radio layers requires a significant amount of compute power, and even then you've got to know what you're looking for, and you've got to be close to it, because as cellular, if you're in a 5G network in building, you've got to be in the building with it. So very difficult to intercept on the radio layer. However, backhaul network protection does need consideration. The weakest links are typically in the wired network somewhere where you've got unexpected tapping, or someone has attacked through a open device somewhere. So keep this in mind. Hopefully we have some Q&A coming up, and we can move on to the Q&A section. Let's have a look. So if you do have any questions, I believe there's a swap card chat environment. If you could place them there, then I'll pick them up. So I do have a question coming in here about what's the penetration of 5G into enterprises today. So let's take that question as, what's the penetration of mobile private networks? This is it's an emerging area. So I spoke to a service provider in Europe 2 or 3 weeks ago, and they were challenging why they needed a slicing solution and what value it would offer them. And they did say to me that, look, we've only got 40 MPMs today. We don't really need this. We're running on an over-provisioning model. Now, 40 MPMs in Europe in one service provider is a very low amount. I mean, they probably support hundreds to tens of thousands of factories. If you multiply that by the number of service providers in Europe, I suggest the number is significantly higher. We know that there's several 100,000 factories and business premises in the UK today. Some, of course, won't adopt cellular technology. Some won't need to go to Industry 4. However, the market is still significant. We expect there will be several 100,000 sites out there eventually across Europe and the globe. So that market is still emerging at present. Just waiting for there's a couple of questions coming up. Just give me a second. Yeah. Okay, so there's no more questions coming through. So I'll just recap a little bit by going back. Oh no, we've done it. That slide I was going to go back up to. So just to close up, Zeta Networks enables you to slice between your service providers and your enterprises, put those data pipes in that you need to manage services as they go across your network. We support both the enterprise, which is the businesses, and we support the service providers, but we support them in different ways. For the enterprise, we create a self-healing portal, so you can go in and change the services you need and request new ones without having to ring a service provider and ask for something. We know that wait times for service providers on the phone can be quite challenging. And then from a service provider perspective, as you add several hundred businesses to your network with 5G mobile private networks, then you are going to need to manage the data pipes that are going to and from those solutions and make sure that everything in your control is doing what you said it will do. So one of the big areas that I see emerging is whose network is at fault. If you think about it, how often have you blamed your broadband provider for your broadband not performing properly, only to find that your computer's hard drive is completely full and that's why it stopped? It's those sort of problems that service providers are going to want us to help them manage. Just waiting for there's a question coming up on screen. Just give me a second here, or a comment anyway. Okay, so there are no more questions coming through. So I'm going to wrap up by saying you can always contact me at info@zeta.com, or at paul.cooper@zeta.com. Don't be shy to use my personal email address. You can find our site at www.zeta.com, and we have a Twitter handle and a LinkedIn channel to further support people. With that, I'm going to thank you very much for listening, and I hope you've gained a little bit of insight about how 5G cellular can assist in the digitalization and transformation of industry as we move towards Industry 4. Thank you very much.